Guys, and welcome back to winter school. I hope that you all had an awesome break and you jumped up and down, you got some coffee. I know I went to go get a big glass of cold water. I can see just by the look on Buntle's face and watching her working that she's been working really hard, and I hope that's what you guys are all doing too. But don't forget to chat to us, but obviously learning is more important. So what I think we're going to do is we're going to get straight back to the lesson, and let's learn more and learn extra and keep chatting and keep answering that challenge question, because we will be going through it I think in the last 15 minutes of the show. And it's amazing, you guys asked for an hour and a half session, and that's exactly what we've done for you guys. So Tamlin, take it away.
Thanks, Indy. Okay, I hope you've all taken a moment to think about that and to just process what we've actually just done over there. But just for the sake of you who are still a little bit confused, let's go over it one more time. We were told that we were having to find the point from the coordinates of A and B, okay? As soon as you're trying to find two different variables, you know you're going to have a simultaneous equation, okay? So the guiding thought there is that we're going to have to kind of formulate two equations based on the information that we have that is going to involve the coordinates of A and B, okay? And by doing that, we are then able to solve the two equations simultaneously and get those two values, okay? So we had to involve the coordinates of A and B, and obviously they gave us this information over here, which is important, okay? Obviously they wanted us to use that. They told us that the distance from the distance of MS, the ratio, to MP is in the ratio of 1 to 3. Now, don't let when you see ratio, I know sometimes you guys get a bit of a fright with that and you're not always sure what to do with it, okay? Remember that when you're working with a ratio, you can write it as a fraction, okay? So instead of writing it as MS to MP, rather write it as MS over MP, and that's equal to your 1 over your 3. It just makes it a lot clearer in terms of working out and actually just to make an equation out of it. Okay, so when you see that ratio, that's what you need to do with it. Cross multiply your ratios, okay, that landed up giving us our 3ms, which is equal to MP. And as I said to you earlier, when we're working with distance formula, your distance formula doesn't say ms equals and then the equation on the other side. We have to work with ms squared, okay? So that was why we put the squared over there, so that we're talking about it in terms of its distance. Okay, having done that, just to quickly recap, we said that we already knew the distance from M to S, so by calculating all of that out, we got 162. And we took the coordinates from M and of P, and we filled it into our distance formula, and we landed up with our negative 2 minus A squared, and our 1 minus our B squared, okay? And that gave us our equation 1. Okay, so that was all based on distance, and it was all based on that ratio that they gave us, okay? We then had to now go back to our diagram, and we had to find another equation. We have to find something that we can formulate an equation out of, but remember that it has to involve AB. We're trying to solve for AB, so we need to include this point somehow, okay? Now, again, tangents, as soon as you've got a tangent and you've got a radius, there's a very, very high possibility that you're going to be talking about those perpendicular gradients, okay? So because you knew what the coordinates of S was, and you knew in terms of A and B what the coordinates of P are, okay? We were able to work out the gradient from S to P, and the gradient of the tangent was perpendicular to it. And remember that we said earlier that the gradient of this tangent was 1, okay? So we knew that. So therefore, this 1 multiplied by the gradient SP has got to equal negative 1. That's the formula that we know for perpendicular gradients, okay? So having done that, let's just go back down here. We took our gradient from P to S. Here we actually had to work out the formula. Very quickly, may I answer a question that somebody put on Facebook? Somebody asked, is it important as to the order? Do you have to say y2 minus y1 over x2 minus x1, or are you allowed to swap them around? The answer to that is that you can swap them around, okay? But the important part is this. If I write y2 minus y1, it has to be followed underneath by x2 minus x1, okay? If you were to put it the other way around, if I say y1 minus y2, underneath it then must be in the order of x1 minus x2. So as long as you're not mixing up the coordinate points, that's fine. But you can either make it y1 minus y2 or y2 minus y1, as long as what's underneath corresponds with that, okay? Right. And by doing that, just very quickly with the working out, we get an equation that said that b was equal to negative a minus 1. Okay. That's really the hard part done, if you can believe it, because now what we're going to do is we're going to substitute if b is equal to negative a minus 1, okay, we are going to take this equation over here, and where we see b, we are going to replace it with negative a minus 1. Okay. All right, so let's just quickly write it out. 162 is equal to negative 2 minus a squared. 162 is equal to negative 2 minus a squared plus, and we had 1 minus b squared. B squared. Okay. We are going to now write this equation out again. So I've got negative 2 minus a squared plus 1 minus, but what we're going to do is that instead of b, I'm going to replace it with negative a minus 1. Let's go back to our purple, and it's being squared. So can you all clearly see where that substitution took place? Okay. Now it's a case of a whole lot of working out. Foil this bracket. Please do not just go squared, squared. Okay, remember when you have a binomial that is being squared, you have to foil it out. Okay, so therefore negative 2 squared is going to be 4. When we do our step of our outers and our inners, we're going to land up with positive 4a and plus a squared. Okay, if you want to do all the steps of FOIL there, you can do it. I'm just saving a little bit of time. Okay, and I've got 1 negative, and a negative is now going to make positive a plus 1, and that's going to be squared. Okay. Okay, we've got 4 plus 4a plus a squared. And now this over here, we've got a plus 2, and again that's going to be squared. So again, you're going to have to do FOIL there. Okay. Steps like these are not difficult steps, they're just steps that you need to be careful, because now you're just working through the motions. You're kind of getting rid of brackets and you're foiling out and you're doing all the things that you need to do. So I've got a squared, I've got 4a, and I've got 4. Sure, okay, right. Last thing, we're going to add up like terms. I've got an a squared plus another a squared, which is 2a squared. I've got a 4a and a 4a, which is 8a. I've got a 4 and a 4, which is going to be 8. If I bring my 162 over, 8a, and that's going to land up being, let's just quickly get our calculator here. I've got 8, and I'm going to subtract 162 from it. Okay, so we're going to get negative 154. Okay. Right, at this step over here, I hope you can all see that there's definitely a highest common factor of 2, which is going to be able to come out. Okay, remembering that that side now is equal to 0. So because it's equal to 0, we can take out the 2 and we can drop it. It goes, okay. So we're left with a squared. I've got 4a minus, and when we divide that by 2, we get 77. Okay. Right, this is now starting to look a lot more manageable. We're getting it down to just a normal quadratic equation. So what we are now going to do with it is we are going to factorize. And the factors of 77 that are going to get us a little 4 are going to be 7 times 11. Okay, the difference between those is 4, and we're looking for a positive 4. So my 11 needs to be the positive, and my 7 needs to be the negative. Finally landing up giving us an a which is equal to 7, or an a which is equal to negative 11. Now, if we look at our diagram, we can see that our value for a is a positive. It's definitely a positive x value. So therefore, my x value for a is 7. Okay? Now we need to take that 7 and we need to substitute it into either equation 1 or equation 2. Choose the equation that is going to make your life easier. Okay? Don't go and sub it into the one that's more difficult. Choose the simpler equation, which I'm sure you'll all agree with me is equation 2. Okay? So equation 2, which was b equals negative a minus 1. So b equals negative a minus 1. And you agree that we've already just solved that a is the value of 7. So we're going to say negative 7 minus 1, and we get an answer for b of negative 8. So finally, we have solved for the coordinates of p, which is going to be 7 and negative 8.
I don't know about all the mindsetters out there, but my brain hurts. Like it's on fire right now.
The important thing to do now is go back and look at it, okay? You've got to look, it's not about the sum itself, it's about the concepts that are sitting behind it, okay? You've got to know things like if you are solving for two variables, your starting point is you looking at a simultaneous equation, okay? Because you're working with a simultaneous equation, we've got to formulate two equations that are going to involve your coordinate of p, okay? And that can be many possibilities. We could be using distance, we could be using parallel gradients, perpendicular gradients. There's a lot of theory behind that, but point is, as long as you sticking to your theory, and you're not making any silly mistakes with theory, there's often more than one way around a sum in analytical geometry. And that's important to remember. So make sure you are very solid in your theory, that if you look at something and you know that be willing to try things. That's important advice as well. Be willing to give it a try as long as what you are trying is very firmly based in correct theory. Okay? And in doing that, you will, sometimes it may take longer than others, but you will get there. And if not, you are certainly picking up points and marks along the way. So it's never ever worth just leaving a question out. Okay, but the main moral of this story is know your theory. That's important. Okay.
Cool. Tamron, I think we're going to take a little break. Phew. Okay, yeah, I think you guys need a bit of a break. I think everyone's breaking out in like a sweat here in the studio. Okay, guys, that's what we're going to do. Please post your questions. I think we're nearing up to the last half an hour. That means that the competition will be closed at about 12, but we'll allow it for during the break. Get those questions, get your answers in quick and fast, and then post all the questions and things that you are struggling with. We will be taking your questions at the end of the show. This is the time now to put all your ducks in a row, to learn more and learn extra, and then do awesome in your prelims, and then just do amazing in those final exams. See you now after the break.